Today we're going to talk about how to calculate limiting reactants, excess reactant, and percent yield. Here we have a problem. You need a balanced equation, which we have at the top, and we have two givens. We have 87.3 grams of gallium sulfate that's going to react with 246 grams of barium nitrate. What we're going to want to find is the theoretical yield of barium sulfate. In other words, how many grams of barium sulfate is going to be produced. We're going to want to find out the limiting reactant, which one of these gallium sulfate or barium nitrate are going to run out first, and how much of the other reactant is in excess. So in other words, whichever one of gallium sulfate or barium nitrate is not used, how much do we have left? And finally, we're going to find the percent yield. How much was actually made in the laboratory? Okay, so we're going to start off with the theoretical yield of barium sulfate. You're going to need your periodic table and a calculator. Okay, I'm going to write my first given. We need to work these like two separate problems. Our first problem is 87.3 grams of gallium sulfate. So I'm going to write that down to begin with. Okay, that's our given. And then we are going from grams to grams because theoretical yield we want in grams. So we're going to set our problem up to do a three-step conversion. So first thing I need to do is change from grams of gallium sulfate to moles of gallium sulfate. So using the periodic table, I'm going to find the mass of Ga times 2, S times 3, and oxygen times 4. That comes out to be 427.6 grams and 1 mole of gallium sulfate. Then I want to convert from gallium sulfate to barium sulfate. So that's a 1:3 ratio. So on the bottom, I'm going to put 1 mole of gallium sulfate. And on the top, what we're going to, 3 moles of barium sulfate. Now we could stop there if we wanted moles of barium sulfate, but theoretical yield actually means in grams. So we're going to do one more. We're going to change the barium sulfate moles here to grams. So I need to use the periodic table and look up the mass of barium plus sulfur and 4 oxygens, which comes out to be 233.39 grams. So what we're going to goes on top, and the 1 mole of barium sulfate on the bottom to be able to cancel out the barium sulfates. Our gallium moles canceled out, and our grams canceled. Okay, that if we use our calculator and figure out that answer, we get 143 grams of barium sulfate. Now we're going to do the very same thing, but we are going to use grams of the given, grams of barium nitrate, the other given. So we're going to start with the 246 grams of barium nitrate. And we want to go to grams of the exact same thing so we can compare answers. So we're going to go to grams of barium sulfate. First thing I need to do is find the mass of the barium nitrate. Using the periodic table, I found it to be 261.34 grams and 1 mole of barium nitrate. Now we want to convert from barium nitrate to barium sulfate, and that is a 3:3 ratio. So for every 3 moles of barium nitrate, there is 3 moles of barium sulfate. Okay, finally, we're going to do the exact same step that we did in the first part here because we want to go to the exact same thing. So we're going to put for every 1 mole of barium sulfate, there is 233.39 grams. Using our calculator, we're going to find the answer to that problem, which comes out to be 220 grams of barium sulfate. Now we need to decide, what is the actual theoretical yield? Is it 143 grams or is it 220 grams? Our answer would be 143 grams, the smaller of the two, because what this is saying is that as we make 143 grams of barium sulfate, we are actually out of this gallium sulfate. So if we're out of gallium sulfate, we can't continue to make more barium sulfate. So we're actually answering part A and B at the same time, because when we find out the lowest amount of barium sulfate that's going to be made, we're going to find out which one caused that lowest amount to be made. So this is the theoretical yield. This is the answer to part A. And the gram theoretical yield, what caused this to be made, is our answer to the limiting reactant. So our limiting reactant is gallium sulfate because it is the one that ran out. So it was limiting because it's all used up. Okay, so by doing those two problems, we actually answered part A and B of our question. So A and B usually always go together. Sometimes the limiting reactant is placed, they put that as part A. So you need to read part B to know what you're going after for your reactant. Okay, our next problem, part C, is how much of the other reactant is excess. So since the limiting reactant was gallium sulfate, the barium nitrate must be in excess. So what we want to know is the grams of barium nitrate that is in excess. Now we know when we're done, the gallium sulfate, there's going to be 0 grams left because all of it's used up. So to solve this problem, that's what we're going to start with. We're going to start with the number of grams that we know will be all used up, and then that will tell us how many grams of barium nitrate will also be used. Not how many is left, but how many grams will be used. So I'm going to start with the 87.3 grams of gallium sulfate. And I'm going to go to grams of barium nitrate. So again, we're going to have 3 conversions. Okay, so the first thing I want to do is change these grams to moles. So we already have the mass that we found before, which is 427, not 426. So 427.6 grams in 1 mole of gallium sulfate. Then we want to convert from gallium sulfate to barium nitrate. So it's 1 mole of gallium sulfate for every 3 moles of barium nitrate. Okay, and finally, I want to go to grams of barium nitrate so I can know how many grams were actually used. So for every 1 mole of barium nitrate, I just had to look above and get my mass from barium nitrate before that we found earlier, which was 261.34 grams. Now I find that answer, which ends up being 99.4 grams. That's how many grams of barium nitrate was used. All right, so now to find out how many's left, I'm going to take my original amount, 246 grams, subtract off how many grams were used, and I get there was 146.6 grams left. Now I need to use significant figures, and when we subtract, we use least number of decimal places, so we're going to actually round this to 147 grams of barium nitrate. That is how many grams we would have left to do another reaction. So that is how much extra we actually had. So we had a lot of barium nitrate left. Okay, then for our last, it's the easiest problem, is percent yield. For percent yield, you simply need, what this is actually describing to us is when we do a lab, we never get the exact amount that they think we're going to get, which earlier we said our theoretical yield was 143 grams. So we do a lab, we normally won't get all those 143 grams. So what percent did we get that we were supposed to? So our equation is percent yield equals the actual yield, so that is actually what's given to us in the problem up above, over our theoretical yield, which is what we calculated earlier, and all that is times 100. So percent yield is what we're going to put on top is the actual, which is what is found in the lab, or in this case given to us in a problem, 138 grams. Earlier we found that the theoretical yield was 143 grams. That was the actual amount of barium sulfate produced, or the actual amount that should be produced, times 100. And I find out that we have 96.5% of percent yield.